Mm, just a second. So do you see the screen?
Yes, sir.
Yes, sir.
Okay, as you know that in the previous class we had a presentation and only two persons are given the presentation. For the rest of you, I think everyone has already submitted it except Balraj. He even hasn't joined the group yet on Google Classroom, so I will ask him to join. So your presentations are pending for uh, five of you, Sanidhya and Agam. They only have given the presentation, and rest of all we are yet to give it. So we will decide a time when we will get some uh, schedule in within the lecture itself, maybe on Thursday or some day else. Then we will go with it. Okay, or we can plan it on Thursday itself. For the first half an hour we will go with the presentations, and for the remaining 20-25 minutes we will have the class. Okay, so for the first chapter has been completed, it is finished. So I have already shared the PPT with you, and I also have shared the book with you. Okay, just go through it. So the book which I shared with you today, the soft copy through email, so you know need not consider the whole part of that book. Only first two chapters are associated with that book. For the remaining chapters, a separate textbook is there that I will share in few days when we will start with that chapter number 3. Okay, so in that particular book, the first chapter, that is the introduction part, you need to see and just compare it with the PPT. So you may be getting some topics in the second chapter also. Okay, so first two chapters of that book, that is the introduction part, and a separate fifth or sixth chapter is there that is based on digital logics. So these two chapters you need to cover it from the book. Okay, when you have gone through the book, then we will discuss that what exact part you need to refer. Okay, then we will discuss. So starting with the chapter 2, that is the digital logics. Okay, so what is digital logics? So these are the contents we would be covering in this chapter. That is the introduction to digital logics, various logic gates, application of these logic gates, what is sequential logic, and the conclusion part. So you are familiar with logic gates, you have studied them at your school time also and at various levels. So we will be just covering those in very brief time, and mostly we will be concentrating on the applications of logic gates. Okay, so how they are used to design various logic gates and their various sequential logic controls. And in the end they will be having application in, you can say, one example which you will be studying covering in this is PLC. So PLC is basically based on logic gates. So we will see how it works. Not the PLC, but how the logic gate works, how the sequential control in logic gates work. And in the end, when we will study PLC, we will correlate it with these topics. So a little introduction to digital logics. So the word digital logics, what does this word mean? Okay. So if you see this, just a second, yes. The definition of digital logic. So it is made with two words, that is digital and logics. So digital mostly constitute of two digits, 0 or 1, or we can say on or off. So there is a very simple logic behind digital systems, that is on or off. Combination or on or off, or 0 or 1 can make a number of combinations. We have already discussed that if we have a number of bit systems associated with the control system, then the number of bits which are available with us raised to the power 2 raised to the power number of bits available, let it be 8. That is the number of combinations of 0 and 1 you will get. So this numeric 2 comes from either 0 or 1. So two values are associated with digital systems. Okay. So we will just read the definition. The control system that are concerned with setting events in motion or stopping them when certain conditions are met are fulfilled through digital logics. Okay. So digital logics is just a control system which works on digital system that can be used for setting an event or stopping an event from occurring. That means on and off. So their input will also be in on and off, and their output will also be in on and off position. So digital circuitry, that means digital circuits are the basis of digital computers and digital microprocessor control system. So whenever we are discussing or talking of digital computers or digital microprocessors or digital systems, that means they will be working on, or they will be based on digital circuitry. What is digital circuitry? Digital gates or digital logic gates, when they are number of gates when they are connected to each other through some combination, then it will constitute a circuit. Okay, so one logic gate and number of logic gates, they are connected to each other to give you some output, desired output, and that output will always be in the form of on and off, on and off. So इससे जो हमें whatever output we are getting from digital system is always in the form of on and off. So you make a combination of circuits in such a way, or design them in such a way that you get the output in on and off position. So for attaining that, for giving number of combinations for that, you can increase the number of outputs, you can increase the number of inputs also, you can connect that system to number of input systems, then whole of that constitutes of a digital circuit. So digital circuit will be a combination of number of logic gates or digital logic systems, small digital logic systems connected to each other either in series or in parallel. They will give you a digital circuit. Okay. So that is what we have set now. There are two input signals which may be either in yes or no signal position, and an output signal which is also in a yes or no signal position. Such an operation is called or is controlled by a logic gate. So simply where you will associate a digital logic system, or where you will install a digital logic system, if you have identified a system where you want an automation to occur in such a way that your input is also in on and off position or yes or no position, and output is also in the form of yes or no or on and off position. So इसका simply example है कि I want my machine to start automatically when these 2 to 3 conditions are fulfilled. That means my power supply from uh, from the back is in the on position, okay, and my worker is at the proper location where I desire them to be at that location, and that location will be sensed by a sensor. So when suppose these 2 conditions have been fulfilled, my machine should start working or it should turn on. If none of this condition is or one of the condition hasn't been fulfilled, then the machine should not turn on. So this is one example. So we have number of examples of such type where you want your system to just turn on and off with the fulfillment of certain you can say with the fulfillment of certain desirable conditions. Okay, so that will be a type of digital circuit which will be associated with it. Just a second. Okay, so identifying a system which can work on some input signals that require just yes or no signals, and your output also requires a yes or no signal or an on and off signal. Such type of control system is associated with or controlled with a logic gate. Okay, and these logic gates, when they are associated with each other in number of additions or subtractions, they form a digital circuitry. Okay, so next is combinational logic. So that is what we were talking, that the term combination logic is used for combining of 2 or more logic gates to form a required function. Okay, so combinational logic, that means the logic or the what is the logic? Logic is some mathematical relationship which is being fulfilled for acquiring some output, or it is a protocol, set of protocols which are driven by some mathematical rules. Okay, so that is a logic. So if you form a combination logic by different logic gate, the hardware for that will be called a digital circuit, but the soft thing which is happening, or the protocol which is happening, that is called combinational logic to attain a required function. Further, sequential digital logics is used when a specific sequence of operations are required. So we have studied a sequential control systems where sequence of operation, as in washing machine, the example of washing machine which we have studied, that when one operation occurs, then the other operation should occur after that or after some time period. So that is a sequential control. So for sequential control also we can use digital logics, and that is called a sequential digital control system. Okay, so I hope this is well understood by you. Is it clear? The introduction to
Yes, sir.
digital logics, is it clear?
Yes, sir.
Okay, thank you very much. So next is the logic gates. So what is a logic gate? So logic gate are the basic building blocks for digital electronic circuits. Okay, so we know what is a digital logic gate. So again, it is made of two words, logic and gates. Logic is set of protocols, and gate is some, you can say it is what in general terms the gate word means that you want your conditions to be fulfilled in such a way that the pathway opens up or closes to let some output occur. ओके जैसे एक सिंपली गेट का मतलब है कि गेट ओपन होगा क्लोज होगा then only you can move out of some place. That is a simple gate. In digital logic gates, a relationship when fulfilled, then only it will allow the thing to happen. Otherwise it will not allow the thing to happen. That is why it is called a gate, because it can block the things which are happening, or it can open the flow of things if some condition has been fulfilled. That is why it is called a logic gate. Okay, so that means for allowing a digital circuit to form and digital logic to flow, we require some gating system such that we can restrict the flow of uh, current or flow of data, and we can allow the flow of data. Okay, and we know that in digital form there cannot be some partial data which is flowing. There should be a full-fledged data. Either it will be 0 or it will be 1. It cannot be 0.5, it cannot be 0.6. So that is why we want to place a proper gate working on some digital logics or digital rules such that it will only open when some conditions have been fulfilled, or it will block those the flow of data from itself. Okay, तो कहने का मतलब है अगर आपको डिजिटल सर्किट फॉर्म करना है तो आपको डिजिटल गेट्स चाहिए, ताकि कुछ स्टैंडर्ड गेट्स हैं जो कि फ्लो ऑफ डाटा को एक स्टैंडर्डाइज तरीके से रोक लेंगे. So you have set relations and set of rules which will guide the flow of data in given conditions. So how these digital logic gates are described? They are described by their Boolean expression. Boolean expression is nothing but a mathematical relation. A table would be there which will be describing the relationship between input and output. That is called the truth table. And there will be a specific signal for each logic gate, and there will be a working circuit diagram for each logic gate. So 4 things are associated with each logic gate: a mathematical relation, that is the Boolean expression; a table showing the relationship between input and output, that is called the truth table; its symbol and circuit diagram. So symbol and circuit diagram are different. So circuit diagram will show the connections, and symbol will just be a symbol which will determine which type of gate has been used. Simple as that. Okay. Is it clear the meaning of logic gate? The set of relations, digital relations, which are allowed through a specific gate or specific path, such that the path will only open when certain conditions have been fulfilled. That is why gates are used. The word gates is used. So simply we know this is very much common thing which you have learned in number of your previous classes. AND gate is there, OR gate is there, NOT gate is there, NAND, NOR, XOR. Okay, so these are the 6 standard gates which are normally used. Although we can get a number of other gates also by the combination of these, but these are the standard gates which are used. Everything else can be obtained from the combination of one or the other. Okay, so 6 gates are there. So we'll just do it quickly. AND gate. We know AND gate, when both the conditions are fulfilled, then only you get an output. That means you have connected both the circuits or switches in series. When both the switches are turned on, then only flow of data will be, or current would be there, and you will get an output. Okay. Okay, so the Boolean expression, or the Boolean expression is simply given by the multiplication signal between the two input signals A into B. So for obtaining an AND gate, we require a minimum of two input signals. So 2 input signals are required in minimum. Although it can be obtained for 3 and more signals, but 2 minimum input should be there, then only an AND gate will be applicable or obtained. And if you want your system to work in such a way, then when both the switches are on, then only you will get an output. That is the AND application of AND gate, or you will use an AND gate. And this is simply the symbol. This is also the symbol used. This is an alternative symbol, but most commonly used symbol is this one. Okay, this one. So you draw it like this, and A and B are the inputs, and output is A multiplied by B. Okay, so Boolean expression, this is the symbol, this is the truth table. What does this truth table shows? Then when both the inputs are 0, you will get a 0 output. One of the symbol is one of the signal is on, that is 1, then also the output is 0. Output will only be obtained when both the inputs are 1. In all other combinations, the output will remain 0. So this is the circuit diagram, which is showing that the input signal A is provided like this. तो ये जब डिजिटल सर्किट पे इसको शो करते हैं तो उसका क्या मतलब है कि यहाँ पे 0 है, यहाँ पे 1, यहाँ पे 0 है, over it is 1. So this circuit or the graphical data is showing values like this. When this is the bottom line, this is the value 0, and when this is the upper line, this is 1, and this is drawn against time. So you see, there is no ये भी एक सर्किट बन सकता है ना डायग्राम की, जब 0 से 1 गया हमारा वैल्यू, तब it increased gradually rather than instantly. Here it is showing an instant rise without any delay in time. But if you get this much of time t value, then that means this is not a digital system, because in digital system you will have either 0 or 1, but for this time there were number of fractional values also which are not part of a digital system. So digital system will always have an instant rise. So this is how you will identify a digital system from an analog system, that you will get an instant rise from 0 to 1 without any delay in time. Okay. This is important thing. So all the three signals are digital signals. So here for A input, you have suddenly applied or turned on this A signal. A सिग्नल टर्न ऑन हो गया, पर B तो अभी भी ऑफ है, तो यहाँ पे आपको Q पे कोई आउटपुट नहीं मिलेगी. फिर आपने A को ऑफ कर दिया, पर थोड़ी देर बाद you have turned on the B signal, but again you will not get any output because now B is on but A is off. At this time both A and B are turned on, so here you will start getting the output for Q. It will again turn off the instance you have turned this off. One of the signals has been turned off, so it will suddenly fall or turn off. तो यहाँ तक फिर दोनों ऑफ है, तो कोई सिग्नल नहीं. फिर यहाँ पे ऑन हो गया ए, फिर भी कोई सिग्नल नहीं. पर जैसे बी ऑन हुआ, ए पहले ही ऑन था, दोनों ऑन हो गए, तो इतने टाइम के लिए आपको आउटपुट मिलेगी. फिर ए ऑफ कर दिया, जैसे ही एक भी ऑफ होगा तो आपको आउटपुट 0 मिलेगी, एंड सो ऑन. So you will get only output when both the signals are simultaneously on. So this is the circuit for the AND gate. So I hope it is understood. Everything, Boolean expression, symbol, truth table, circuit. Is it clear to everyone? Clear or not?
Yes, sir. Clear.
Clear, sir.
So everybody is listening attentively, or you are just busy in some other activities? So everybody is with me?
Yes, sir.
Yes, sir.
Okay. So
Yes, sir.
please be attentive. Okay. So somebody has left the class in between, I think. Who is that? Agam is there, Prabhat, Raj, and Rishabh. Vibhor is not present, na? I think he was present previously. He was the first to join. Okay, no problem. Maybe some technical issue. Next, then comes the OR gate. So OR gate, we know, as the word says, OR. Either of the one signal is offered, you will get an output. Okay, चाहे A है चाहे B है, कोई भी दोनों में से एक गेट भी ऑन है तो हमें आउटपुट मिल जाएगी. दोनों का ऑन होना जरूरी नहीं है, ठीक है. कई बार हमारे पास घर में भी स्विचेस होते हैं which can be turned on from two places. Like in the staircase, we normally put two connections, one at the first level and other at the ground level. So the light or the circuit can be turned on from either of the place. That is the example of OR gate. That means you get either A or B, you will get a Q as the output. So for that, we need to connect the circuit in parallel, not in series, like in the case of AND gate. So what will happen if A opens, then the current will flow from this direction, or the circuit will be complete from this direction. If B is there, then it will complete from this direction. And if both are there, then it will automatically complete from either direction. That is not our concern, but it will be completed. That is there. Okay. So for this also, we require two minimum signals, input signals, for obtaining an output. So for OR gate also, we require minimum of two input signals for getting an output signal. Okay, ji? So this is the symbol for the standard symbol for the OR gate. ठीक है, पिछले वाले पे कुछ ऐसा था, AND gate पे, इसमें it's like this. Okay. So you need to remember these signals. They are very important, because when you will get the overall circuit, there it will be showed by symbols only. So AB output is A plus B. This is another alternative signal, oh sorry, symbol that can also be used, but this is the most commonly used symbol. Okay, so the truth table is this one, that any of the signal when is 1, you will get an output. दोनों जब 1 है तब तो है ही है, एक भी जब 1 है तो आपको आउटपुट मिल जाएगी, otherwise it will be 0. Here you see the circuit, A यहाँ पे ऑफ है, जैसे B ऑन हुआ Q भी ऑन हो गया, जब दोनों ऑफ है तभी ये ऑफ रहेगा, फिर जैसे ही A ऑन हुआ then again Q is on, and again when simultaneously B is on, Q is still on, A is off but B is on, Q is still on. थोड़ा सा यहाँ पे फर्क है, it should have been extended to this, है ना, यहाँ तक होना चाहिए था, it should be over till here. Then again if A starts then Q also starts. So used when any one of the signal is on, so it has a parallel circuit rather than series, as in case of AND gate, and its symbol is A plus B rather than A multiplied by B. Then comes the NOT gate. So NOT is very simple, it is the inverse of the input signal. NOT is simply the inverse of the input signal. So it requires one input signal to obtain an output signal using a NOT gate. So NOT gate के लिए सिर्फ एक input signal से भी काम चल जाता है, ठीक है? So it has this symbol, common symbol, triangle के आगे this small circle. This shows a output NOT gate. Sorry, this is the not so commonly used output symbol. ठीक है, ये जो इसका सिंबल, इफ यू सी दी सिंबल्स जो दूसरे ऑल्टरनेटिव सिंबल्स है, इसमें ये फायदा है कि इस पे सभी पे स्क्वायर ब्लॉक्स आपके यूज किए गए हैं, साथ में अंदर इसके बीच में दे हैव पुट सम सिग्नल लाइक फॉर AND gate such signal was there, for it this type of signal is there, and a small circle. तो ये बेनिफिट है इसको याद रखने का कि इस पे सभी में स्क्वायर ब्लॉक्स ही यूज होंगे, बट इसके अंदर जो वैल्यूज है दे डिफर, ठीक है, बट ये जो स्टैंडर्ड सिंबल्स है इसमें ये शेप्स भी डिफर करती है. So I recommend you remember these symbols. We will be using these more commonly. ठीक है जी, नॉट गेट का क्या हो गया, सिंपली you will get an output when there is no input and you will get no output when there is input. So written like this, A mod. So 0 जब ये 0 है तो ये 1 हो जाएगा, जब ये 1 है तो ये 0 हो जाएगा. तो सिंपली जैसे ही ये सर्किट 0 था, यहाँ पे आपको आउटपुट मिल रही थी, जैसे यहाँ पे इनपुट दी, ये आउटपुट 0 हो गई. So it is just a mirror image which is obtained in this case. ठीक है, so this is the NOT gate. Then comes the NAND gate. NAND gate is nothing but combination of two gates where AND gate is followed by a NOT gate. So NAND का आधा वर्ड क्या हो गया, AND के बाद अगर NOT gate आपने लगा दिया तो वो बच जाएगा NAND gate. Okay. An alternate way of considering the gate is that AND gate with the NOT gate applied to invert both of the inputs before they reach the AND gate. तो कहने का मतलब है कि इसको ऑल्टरनेटिव वे से भी हम ऐसे भी कह सकते हैं कि AND गेट जिसकी NOT गेट, हर दोनों इनपुट्स पे आपने NOT गेट लगा दिया, that can also be considered as a NAND gate. Okay, so इसका सिंपली क्या होगा, we know AND गेट का ये होता है AND to B बूलियन एक्सप्रेशन, उसके ऊपर NOT गेट का कंप्लीट मॉडुलस लगा दिया, so it becomes the NAND gate. So we are putting it in series. This is the symbol for AND gate and this is the symbol for NOT gate. When both put in series, you will get the output over here. So in between, this is the intermediate input after the AND gate, and this is the final output after the NAND gate, complete NAND gate. तो दोनों को यूज करके एक सिंपल आपका जो सर्किट है इट विल बिकम लाइक दिस. सो ये वाला सिंबल हम AND गेट से उठाएंगे और ये जो स्मॉल सर्कल है दैट इज फॉर द NOT गेट. सो दिस इज द सिंबल फॉर द NAND गेट. ओके. सो हियर व्हेन वी विल डू इट, तो इसका इंटरमीडिएट अगर देखिए तो जीरो AND गेट पे क्या होता है, जीरो जीरो का क्या होता है, जीरो है ना. इन AND गेट व्हाट हैपेंस, 0 0 0 0 1 0 1 0 0 1 1 1. तो इसको जब रिवर्स कर देंगे तो 0 का 1 बन गया, 0 का 1 0 का 1 एंड 1 का 0, एंड प्लस नॉट नेट. तो नैंड गेट की अब क्या देखिए, अब आपको इसका यू हैव टू आइडेंटिफाई इट्स सिग्निफिकेंस. क्या सिग्निफिकेंस है इसकी, ये गेट वहां पे यूज करना है जहां पे दोनों इनपुट जब ऑन हो हमारे, तभी हमें जीरो आउटपुट मिले. बाकी सभी केसेस में हमें आउटपुट मिलती रहे चाहे इनपुट जैसी भी हो. सो दिस इज द यूनिकनेस ऑफ दिस गेट, दैट जैसे ही हमारी दोनों की इनपुट 1 हो जाएगी then your output will become 0, otherwise it will, the output will always be there. तो कहने का मतलब है अब हमें एक मशीन को ऑफ करना है तो हमें उसके दोनों स्विच जो होंगे ऑन करने पड़ेंगे तब वो ऑफ होगी, अगर ऐसा कोई सिस्टम आपको चाहिए. अदरवाइज यू विल ऑलवेज कीप ऑन गेटिंग द आउटपुट. तो ये कहाँ पे यूज होता है, ये होता है आपका switches which are called I don't remember. आपने कभी कई मोटर्स में देखा होगा कि आपके जो स्विचेस होते हैं when you press it they will keep on running. अगर अब आप जब तक उसको दोबारा से प्रेस नहीं करेंगे तब तक वो ऑफ नहीं होगा. So it's, we will see it in detail in the coming chapters also. I don't remember the exact name of that switch. The switches are there which require actually again pressing them only, then the machine will come to an halt. एक तो ऑन ऑफ टाइप के स्विच होते हैं, एक होता है कि पुश बटन टाइप के स्विच होते हैं. ठीक है. सो इन पुश बटन टाइप ऑफ स्विचेस what will happen, it will trigger the system and come back to its default position, and the system will keep on running until you again press it and again trigger the system back. There the NAND type of circuitry is used. Okay, so we want that circuitry where the system just keeps on running on its own. चाहे पीछे आपका कोई भी चीज ऑन हो रही है ऑफ हो रही है उसको कोई फर्क नहीं पड़ रहा, जब तक दोबारा दोनों ऑन नहीं होंगे तब तक वो चीज ऑफ नहीं होगी. Such type of system uses a NAND gate. Here also you can see in the circuit diagram, when A is off, B is on, then Q is on. But for the time where A and B both are on, Q will be off. But for the remaining part, it is still on, and it is off again when A and B both are on. Clear? Clear till this part or not?
Yes, sir, clear.
Okay. Then comes the NOR gate. Now, like the NAND gate, NOR gate is OR gate plus NOT gate. That means A plus B whole modulus equal to Q is the Boolean expression. And this is the symbol. Like this is the symbol for the OR gate, and then for NOT gate, small circle is there. This is the output. And again, intermediate output is of the OR gate. Okay, so this is the standard symbol which is used. This is the alternative symbol which is used. Okay, it's like that. Here also you see what is happening. For OR gate, we are getting 0 0 0 फॉर एवरी अदर थिंग वी आर गेटिंग इट 1, तो इसको हमने नॉट भी लगा दिया इसमें, so it is like this. So very unique circuit. When both the signals are off, that only you will obtain a on signal. For any other combination, the output is off. ठीक है, ये इसकी ये यूनिकनेस है कि जहां पे आपको इस टाइप का सिस्टम चाहिए कि जहां मेरे दोनों इनपुट जब जीरो है, कहने का मतलब जब दोनों इनपुट ऑफ है तभी इनपुट मिले, सॉरी दोनों इनपुट ऑफ है तभी मुझे आउटपुट मिले, अदरवाइज फॉर ईच एंड एवरी अदर कंडीशन दी आउटपुट शुड बी जीरो। ठीक है, ऐसा कोई अभी हमने अभी तक ऐसा कोई सर्किट नहीं पढ़ा था जिसमें दोनों सिग्नल के ऑफ होने पे हमें ऑन आउटपुट मिले, है ना। बाकी चाहे कोई भी ऑन हो, एक भी ऑन हो जाए, एक भी जब ऑन हो जाए उसके बाद आपकी यहाँ पे आउटपुट ऑफ हो जाएगी। तो अगर आपको ऐसा रिवर्स सिग्नल चाहिए तो वहां पे हम ये ऑट नॉर सिग्नल गेट यूज करेंगे। नॉर गेट की क्या यूनिकनेस हुई? व्हाट इज द यूनिकनेस ऑफ नॉर गेट? दैट यू विल गेट द आउटपुट ओनली व्हेन बोथ inputs are off. If either of the input is turned on, your output will become off. तो यहाँ पे इसका सर्किट भी देखिए, यहाँ पे ये ऑन है, ये ऑफ है, इसका मतलब ये ऑफ ही रहेगी। ये ऑन कहाँ पे होगी? जब दोनों ऑफ है, यहाँ पे, और यहाँ पे भी ये जब दोनों ऑफ है तभी आपको ये आउटपुट ऑन मिलेगी। ठीक है जी। So both the NOR and NAND gate are having minimum two input signals are required for these. Then lastly, the XOR gate. XOR gate is also called exclusive OR gate, can be considered as the OR gate with a NOT gate applied to one of the inputs. तो इसमें हमने इसकी एक इनपुट पे NOT गेट लगाना है। तो ऐसे हम देखिए, हम ऐसे सर्किट बनाने का क्या मतलब है? बिकॉज वी आर गेटिंग सम यूनिक आउटपुट्स, हमें यूनिक आउटपुट मिल रहे हैं, इसलिए हमें ऐसे गेट हमने डिजाइन किया है कि अगर हम नॉट गेट को एक इनपुट पे लगा दें तो हमें इस तरीके का कॉम्बिनेशन मिलेगा। ठीक है, सो दिस इज हाउ इट इज डिसाइडेड एज पर द रिक्वायरमेंट ऑफ द इंडस्ट्री और रिक्वायरमेंट ऑफ ऑटोमेशन। जैसे मैंने आपको अभी एक स्विच की, नैंड में स्विच की एग्जांपल दी थी कि मेरा सिस्टम चलता रहे बस जब तक दोबारा जाके हम उसको ट्रिगर ना करें। ठीक है, ऐसी कोई रिक्वायरमेंट आई होगी तब ऐसा गेट बना होगा। ऐसे ही एक्सओआर गेट है, इसमें क्या है, एक्सक्लूसिव और का मतलब हो गया एक और गेट आ गया जो इसका वर्ड बता ही रहा है, और एसोसिएटेड विद नॉट गेट which is put to one of the inputs, not both the inputs, one of the inputs. There you will get some unique combination of inputs and outputs. That is the actual logic of creating this gate. ठीक है? Okay, so here you see that this is the circuit. This shows the OR gate. OR gate का एक इनपुट आ रहा है A और दूसरा इनपुट आ रहा है B. B को OR गेट पे पहुंचने से पहले ही हमने उस पे नॉट गेट लगा दिया, such that this will be the required result A plus B naught. So its symbol is like this. OR गेट को ऐसे शो कर दिया, एक पैरेलल लाइन इसके यहाँ पे शो कर दी, this is how it is shown. ठीक है, अब ये जो इनपुट सिग्नल है, ये नॉट गेट आप B पे भी लगा सकते हैं, A पे भी लगा सकते हैं, तो हमें दोनों कॉम्बिनेशन चाहिए होंगे। तो इसके लिए दोनों कॉम्बिनेशन के लिए वी हैव क्रिएटेड दिस बूलियन एक्सप्रेशन। ठीक है, ये नॉट गेट A पे भी लग सकता है, B पे भी लग सकता है, पर लगेगा किसी एक पे, तो दोनों का कॉम्बिनेशन हमें लेना है। सो A इंटू बी डैश प्लस A मॉडुलस इंटू B. So this is the required Boolean expression. A plus B in bracket multiplied by B dash plus B dash. तो जब इसको सॉल्व करेंगे you will get this output. That means when both are off then also off, when both are on then also on, off sorry, and it will be on only when one of the input is on. ठीक है, तो देखिए कितना यूनिक इसका रिजल्ट है। जब दोनों ऑन है तब भी ऑफ है, जब दोनों ऑफ है तब भी ऑफ है। ऑन कब होगा? जब कोई सिर्फ एक आपका इनपुट ऑन रहेगा, सिर्फ एक इनपुट को ऑन रहना चाहिए। तो अकॉर्डिंगली दिस इज द सर्किट. जब दोनों ऑफ है तब भी ऑफ है, जब एक ऑन है एक ऑफ है तब ऑन है ये. फिर यहाँ पे दोनों ऑफ फिर ऑफ, दोनों एक ऑन एक ऑफ ऑन, दोनों ऑन ऑफ, एक ऑन एक ऑफ ऑन, दोनों ऑफ ऑफ. So this is the uniqueness of XOR gate. So kindly go look for some example which uses XOR gate for its operation in the industry. So kindly look at the on the internet and we can discuss it in the next class. ठीक है, तो आपको पता लगा, इससे आपका थोड़ा सा इंटरेस्ट भी बनता है चीज में कि इसको एक्चुअली में यूज कैसे करते हैं. So kindly go through it and see where XOR gate is used for any of the circuit or any of the system within the industry. Okay, so kindly go through it. So I hope these gates are clear to you till this point.
Yes, sir.
Okay,
Yes.
तो इसके बाद combination of gate that we will do in the next class. For today this is I think sufficient. And आपको इंटरेस्ट है तो you can look into another examples also which are utilizing not the XOR or not only the XOR gate but the NOR gate, NAND gate also. Okay, NOR, NAND, XOR. You can just look in on the internet what are the various examples where these are associated. Okay, so any other question which you want to ask? Any question?
No, sir.
Okay, thank you very much. And what about Vibhor? Why hasn't he joined? Is there any technical issue at his place? I don't know, because he
Oh,
was
no,
the
sir.
first to join. Okay, okay then. Thank you very much.